Good evening, everyone. I am Usman K, Assistant Professor, BITM Ballari. First, I welcome you all to my third video lecture on Model 5. So, in the previous video lecture, we discussed one of the problem on Bezier curve. So, in that problem, we given three control points. So, with the help of three control points, we calculated how many pixels are there in that particular curve and what is the position of each pixel with respect to x-axis and y-axis we calculated. Finally, we substituted u value starting from 0 to 1.0, and with the help of that parametric constant u we calculated what is the position of each pixel along with the x-axis and y-axis. So finally, I drawn one of the Bezier curve. So with the help of that knowledge, today I would like to introduce one of the lab program called designing or developing one menu based program to animate a flag using Bezier curve algorithm. Means today we want to implement one of the lab program on the Bezier curve concept. So one of the Bezier curve is, or one of the application of Bezier curve is, we can implement animation, or we can implement animated images. So today we will discuss how we can create a animated flag using Bezier curve algorithm. So before explaining the basic principle of 8th lab program, first I would like to explain what is the input we need to give to this particular program and what is the expected process we supposed to perform by using Bezier curve algorithm, and finally what is the expected output of this particular program. So as we know already how we can generate curve using Bezier curve equation. Today, first we need to design one flag. That flag contains three different colors. Like first we have orange color. Few lines we have orange color here. Please you see the left diagram. I have a flat surfaces. So this is called a flag is designed with respect to flat surface, and the same flag we want to apply animation to this particular flag. So after applying animation concept to this flat surface flag, we will get a flag with flapping. Means the flag is, it looks like a flapping. So when flag is flapping, the flat surface of the flag is converted into like a curves. So this is the application of Bezier curve. So first we want to create one flag that contains flat surface. But whatever the flag in our lab program we are creating, that flag image does not contains Ashoka Chakra. But with respect to see the second diagram, there is a Ashoka Chakra is there in middle of the flag. But for the lab program, we are not creating Ashoka Chakra. We are creating one flag that contains three different colors. Like we have orange color, we have white color, we have green color surface, and we have a one pole. Now, first we will design flat surface. After designing one flag of the shape called flat surface, we will give motion to that flat surface, that is called theta value. So when we increase the theta value, slowly the flat surface flag starts flapping. So when flat surface flag starts flapping, the flat surface looks like a curved surface. So this is the aim of 8th lab program. Now the question is how to create flat surface image. If we want to create flat surface image, as you can see that we have I designed I designed we have totally 8 8 8 8 threes are 24. So 24 line segments are there. In each line segment we have 20 pixels. So 24 lines are there. In each line we have a 20 pixels. This is about how to create a flat surface. And we supposed to create one pole. This vertical line is called pole. So we need to create one pole for this particular flag. So a combination of one vertical line and totally 24 lines creates one flat surface without animation. When we give motion to this particular flat surface, then each line of the flag, each horizontal line of the flag, it becomes curve. So when you give movement or motion to the flat surface of the flag, each line of the flat surface of the flag, it looks like a curve. So our aim is we need to give motion to the flat surface and we need to change each horizontal line to curved lines like this. This is the aim of 8th lab program. So let us begin with how to design a curved surface or how to design a flat surface. If you want to design Bezier curve, let us consider the algorithm. So I written consider a algorithm to animate a flag using Bezier curve algorithm. So we are using Bezier curve algorithm to create animated flag. Then the algorithm says that step 1 is user or programmer has to enter number of control points. So as per our lab program, whatever the program we written, in that program we are assuming or we are considering four control points. We are considering four control points. Like this is the first step. Programmer has to specify how many number of control points you were selecting. So as per the Bezier curve, we are taking number of control points is equal to 4. Step 2 is we need to enter how many number of pixels are there in each curve. So we are assuming number of Bezier curve points is equal to 20. So whatever the program we written, in that program each curve contains 20 pixels. Step 3 says that use Bezier curve equation and generate a Bezier curve. So whenever we want to generate Bezier curve, we supposed to use Bezier curve equation. So this is Bezier curve equation. P of u represent position vector for each control point and P of u it represent what is the pixel position with respect to that particular curve. and we are using Bezier curve equation where sigma is k equal to 0 to n. So here n value is 4. If n value is 4, then we need to start k value 0 to n minus 1 or number of control minus points minus 1. So 4. 4 minus 1 is nothing but 3. So you assume n is 3, k equal to 0. Because you are starting from k equal to 0, then definitely n value should be n minus 1. n minus 1. Here p of k represent control points value. Control point value. If we need to substitute k value 0, 1, 2, 3. And this BEZ represent blending function. Blending function, and k value ranges from 0 to 3 and n value is nothing but 3. And we know that u is called parametric constant. That parametric constant value u ranges from 0 to 1. But in this program, we are taking total number of pixels is equal to 20. Then u value ranges from 0 to 0 to 1. 0 to 1. And we need to distribute this u value for all the 20 pixels. So we are using Bezier curve equation to create one curve. So after creating one curve by using Bezier curve equation, if you give the curve, motion to that curve, that flat surface, flat line, horizontal line is converted into curved line or curved surfaces, right? So this is the equation we are using. So first step, enter number of control points. Step 2 says that define how many number of pixels you selected in each curve. And step 3 says that calculate what is the pixel position or what is the each pixel position in that particular curve from first control point to last control point in that particular curve. Then step 4, here. See that here. First I written this is the Bezier curve equation and I am expanding what is blending function here. Blending function BEZ is k of n, k comma n is equal to C of nk into u power k into 1 minus u power n minus k, where C of nk is called binomial coefficient value. We know that how to calculate NCR. So NCK is nothing but NCR. And we need to find out NCK formula is n factorial divided by n minus k factorial into k factorial. Next we need to determine what is P of u. P of u equal to, we need to go on substitute P naught, P1 and so on in this equation. In this equation we need to go on substitute P naught, blending function, first k equal to 0, n value is constant 3. Next P1, but here k value is incremented by 1, k value is 1, n value is 3 and so on. This is position vector. Next we need to calculate what is the pixel position, what is the each pixel position in that particular curve with respect to x-axis position and with respect to y-axis position. So if you want to calculate x-axis position, in this equation, wherever p naught is there, write x naught, x1, x2 and x3. And if you want to calculate y-axis coordinate position, in this equation, wherever p naught is there, substitute y naught, y1, y2, y3. You need to stop for up to y3 because when n value becomes 3, we need to stop. When k value becomes equal to n, we need to stop. This is this is the equation we supposed to use to calculate what is the pixel position in each curve. So totally we have 24 curves are there. 8 threes are 24. In each curve we have 20 pixels. For each pixel we need to calculate x axis x coordinate value and y coordinate value, and we need to calculate z coordinate value also, but we are not creating three-dimensional flag. If you are creating three-dimensional flag, then you need to calculate z value also. So I completed step 3. So step 4, after creating curve or after creating 24 curves of each 8 curve of different color. First 8 curves are orange color or saffron color. Next 8 curves are white color. Next 8 curves are green color. So total 24 horizontal flat lines we need to create. After creating 24 horizontal lines, each line contains 20 pixels, then we need to give motion to that flat surface of the flag. When you give motion, giving motion is nothing but increment the theta value. As soon as you will increment the theta value by 1 or 0.1, then that flag starts flapping. When starts when flag starts rippling or when flag starts flapping, then each flat or horizontal line of the flag is converted into curve. So for our eyes, each flat lines, each horizontal line of the flag, it looks like it's a flapping. So when flag starts flapping, that line looks like a curve. When you want to display curve on the screen of the monitor, you supposed to use Bezier curve concept, and you supposed to use the translation. Because why we need translation here means, when you convert each horizontal line into curved line, whatever the pixels you displayed to display each horizontal line of the flag is displayed in the form of curve. So each line is converted from the horizontal line to curve. So the same pixel is translated. Same pixels are translated from horizontal line to curved line. So curved line or curved surface. So when you translate these pixels from horizontal lines to curved line or curved surface or curved shape, those pixels positions are changed. So when pixel positions are changed or modified, then we need to calculate what is the new coordinate position of each pixel from horizontal line to curved line. So this is the concept we need to remember in this particular program. Now we need to use double buffering here, or we need to use multiple buffer. Whenever you are using animation, you supposed to use multiple buffer. So the reason of using multiple buffer is, whenever you are using animation whenever you are using animation, then we need two buffer or double buffering. One buffer In one buffer we need one buffer to read the content from the frame buffer. One more buffer we need to display the current image on the screen of the monitor. So when you give motion to that image, the image will continuously changing the position, coordinate position. For our eyes, it looks like we are getting new image. But we are changing coordinate positions of the each pixel when you give the motion, or when you are creating animated images. We need to create frequently, every 30 seconds. We need to refresh the content of the frame buffer, so that our eye cannot catch whether we are displaying same image or different image. In reality, our processor will read the pixels from the frame buffer and continuously displaying the new images, new image on the screen of the monitor. Only it change the coordinate position within fraction of milliseconds. It will change the coordinate position when we are using animated images, but our eye cannot able to catch those changes. So but what our eye can feel means, our eye feels like it is moving. In reality it is not moving. In reality it is not moving. We return code in a such a way that immediately we are changing the position of the image. Immediately we are changing the position of the image. When you are changing the position of the image, immediately that is hidden from the programmer when you are giving animation to that particular image. So we need translation, we need theta value here, we need theta value, and we need to create first flat surface, and we need multiple buffers. One buffer to read the content from the frame buffer, and one more buffer we need to display the current image on the screen of the monitor. So this is algorithm to create flat surface. After creating flat surface, give the theta value or slowly increment the theta value by 0.1 or 0.10. If you slowly increment the theta value, then that flat surface flag looks like a, it's a flapping, means it's a rippling. That flag is rippling. We are aware of this. What is a flag flapping? So every August 15th, every year August 15th, we will see that the flag is flapping. The flag is flapping. That concept we are using, and our intention is here, we want to create animated image. Animated image, it contains sequence of images with motion. Sequence of images with motion. So we are giving theta value. So giving theta value is nothing but we are giving motion to the sequence of images. So those sequence of images are displayed one after another without flickering. So we know that what is a flickering concept. All these things our eye cannot able to catch, whether whether you displayed new image or you translated that existing image from one coordinate position to another coordinate position. So this is about the algorithm. So let us discuss, out of 24 curved lines, curved surfaces, how we can create one Bezier curve. So if you want to create one Bezier curve in our lab program, we we given four control points. So we are assuming first control point is called P naught. Its coordinate position is 20, 100. Try to observe x-axis value and y-axis value. First control point is at 20, 100. Second control point is I am incrementing 10 pixels with respect to x-axis. If you increment 10 pixels with respect to x-axis, I will get 30. So I have second control point P1 at the position 30, 110. Try to observe y-axis value. First y-axis 100 is there. With respect to plus 10 pixels, I will get one more control point that is called P1. Its y-axis value is 110. I have one more control point P2. Try to observe x-axis value. Now x-axis value is incremented by another 20 pixels. Then 30 plus 20 it will become 50. This is P2, but y-axis value is 90. So already 100 is there. This is 100. Below that 100 is nothing but 90. So this is P2. Finally, P3 is 60, 100. Then totally four control points are there. So we know that Bezier curve. The definition of Bezier curve is, a curve is a points, collection of points. Each point contains neighbor or neighbors, except first and last point does not contain the neighbors. If you see this example, if I want to create one curve like this, if you want to create one curve like this curve is nothing but collection of pixels, and every pixel in this curve having neighbor pixels, except first pixel p naught does not have neighbor pixel left side, and last pixel that is called p3 that does not contains the neighbor that is called right pixel. It has left pixel but right pixel is not there. So this is the definition of Bezier curve. In this program we are creating one Bezier curve using four control points. Along with that four control points, we have a tangent. So totally we have three tangents. That is number of control points minus one tangents are there. P0 to P1 is a one tangent. P1 to P2 is another tangent. P2 to P3 is one more tangent. So the basic building block of Bezier curve is tangents as well as control points. So we have totally four control points are there. But in this program, our aim is our aim is we need to create one flag that contains eight orange colored color or eight orange color curves, eight white color curves, eight green color curves. To create one curve, we are using four control points, three tangents, 20 pixels, and the u value ranges from 0 to 1, 0 to 1. So this is the Bezier curve equation. So as per our program, in our program we have taken number of control points are 4. So here I will substitute n value is 0 to 3. 0 to 3 is nothing but P0, P1, P2 and P3. So P0, P1, P2, P3 are the control points. Now P of u is nothing but position vector. Now if I want to calculate position vector, this is the equation. So we need to substitute P0, k value is 0, n value is 3. Next P1, k value 1, n value 3. P2, k is 2, n is 3 only. P3, k value is 3. Now we need to stop. Now in this equation, it is given. In this equation, it is given P0 value is given, P1 value is given, P2 and P3 values are given. P0, P1, P2, P3 are the control points. Its value is already given in the program. Now in our program, we need to calculate blending function 0, 3 and blending function 1, 3, blending function 2, 3, blending function 3, 3. So we written very beautiful code to calculate blending function. To calculate this blending function, we also need to calculate what is the x and y coordinate position for each pixel in each curve. Totally we have 20 pixels are there in each curve. For each pixel in each curve, we supposed to calculate what is the x-axis coordinate position and y-axis coordinate position. So wherever p0 is there in this equation, I will substitute only x-axis value, x0, x1, x2, x3. x3 is the last because our control points ranges from 0 to 3. So I started first from 0, x0 and I ended x3. Similarly, I supposed to calculate y of u. If you want to calculate y of u, wherever p0 is there in the previous equation, here I substituted y0, y1, y2, y3. I want to stop up to y3 only because our control point starts from P0 0 to P3. Because of this reason, I substituted y value from y0 to y3. Now, if you want to calculate blending function 0, 3, 1, 3, 2, 3, we need equation. So the equation for blending function k, n, it is I written in general. But in this equation, k value 0, 1, 2, 3 is there. In general, I written blending function equation, that is c of n comma k into u power k into 1 minus u power n minus k. This is the equation to calculate blending function for the given value of k comma n. If you want to calculate blending function k comma n, I need to calculate what is the binomial coefficient value. C of nk is called binomial coefficient. It is. We know that what is the binomial coefficient for C of nk. This is nck. NCR formula we know that. So I will replace R to k. Then I will get binomial coefficient equation, that is n factorial divided by n minus k factorial into k factorial. And here our n value is 4. If n value is 4, in our program we are calculating 3c0 k value 0, 3c1 k value 1, 3c2 k value 2, 3c3 k value 3. So whatever I am explaining, we written code for all these equations to give the connectivity between our lab program to tracing part. I am explaining what are the possible equations are there in our Bezier curve. So in our lab program, we are calculating 3C0, 3C1, 3C2, 3C3 by substituting k value starting from 0 and it ends at 3. Ends at 3. And for each curve, we supposed to calculate what is the pixel position. What is the each pixel position? As you see that in our lab program, our P naught is the first control point, P3 is the last control point. So between P naught to P3, we have 20 pixels. Including that, we have a 20 pixels. So the first pixel U value here, we are calculating 0 by 20. 0 by 20. So if you divide 0 by 20, you will get first pixel position U value, that is U equal to 0. If you want second pixel U value, I will divide 1 by 20. 1 by 20, that is for 0.05. Like this, I like this. Last but one pixel, that is nothing but 19 by 20. 19 by 20, that will give 0.95. Last pixel position 20 by 20, that will give 1. So as I said in the previous slide, U value ranges from 0 to 1 only. But how many number of control points you are taking, depending upon that number of control points, you will get a Bezier curve with different shape. But U value always ranges from 0 to 1 only. So this diagram indicates we created one curve in our lab program. In that curve, each pixel, if you want to calculate each pixel position, you need to calculate U value. You supposed to calculate X coordinate value. You supposed to calculate what is the Y coordinate position value. So now in this slide, I am explaining, please you see this example. I am explaining how to calculate U value. So I written clearly 0 by 20, it is the first pixel position. First pixel position with respect to U value. Last pixel position U value is 20 by 20, that will give 1. Why I am taking 20 here means, in our lab program, total number of pixels we fixed into 20. So when you fixed total number of pixels are 20, if you want to calculate U value, I will start calculating U value from 0 and I will end U value by 1.0. This is about how to calculate U value in our lab program. So now I would like to explain how entire program we written and how control is transmitted in our lab program from one user defined function to another user defined functions. So let us see the control flow diagram. So we written our OpenGL program to create a animated flag. So first we know that execution of our C program always starts from main. So in the main, we are calling one of the user defined function called myDisplay. So the myDisplay user defined function, in the myDisplay user defined function, we clearly specified how many control points are there. So total number of control points are 4, and how many number of uh, pixels are there. So we defined number of Bezier curve points are 20. Now my display user defined function, again it calls Bezier user defined function. Now this is a third call in our lab program. So Bezier function pass the three arguments, that is control points are 4, number of control points are 4, number of Bezier curve points are 20. So it will pass three formal parameters, that is control points 4, number of control points 4, and total number of pixels in each curve is called 20. Now our aim is we want to create Bezier curve. Then Bezier curve control, again Bezier curve, again it calls one more function called binomial coefficient. We designed BINO binomial user defined function we written. So binomial coefficient will pass formal parameter, that is number of control points minus 1. Number of control points we know that 4, in our program we have taken 4 minus 1 will give 3. So we supposed to calculate binomial coefficient for 3C0 k value 0, 3C1 k value 1, 3C2 k value 2, 3C3 k value 3. So whatever this 3 I written 3 3 3, this is the n value as per the equation. So binomial coefficient, it will calculate what is the factorial of a given number, and it returns what is the result of 3C0, 3C1, 3C2, 3C3. So if you want to calculate 3C0, we need to call the function factorial, that is factorial n factorial divided by n minus r factorial into r factorial. So that function internally calls factorial function, means we are using recursion here. We are using recursion. Recursively we are calling factorial function, that is nothing but binomial function. So Bezier curve will call binomial user defined function. Binomial user defined function will call factorial function to find factorial of a given number. Factorial of a given number. This binomial coefficient function returns what is the result of 3C0, 3C1, 3C2, and 3C3. And I return here after calculating what is the binomial coefficient for 3C0, 3C1, 3C2, 3C3, this Bezier curve also calculate what is the u value. So the u value ranges from 0 to 1.0, but total number of pixels are 20. So first we are dividing 0 by 20. Here I written formula k by 20. So in the previous slide I traced this. First time k value 0, 0 by 20, you will get u value for the first pixel. When k is incremented by 1, k becomes 1, 1 by 20, it becomes u value for the second pixel. Like this we will go on substitute u k value 20 up to 20, 20 by 20, that will give 1.0. So u value we are calculating in each iteration we are calculating u value. So assume that we calculated first time u value, that is 0 by 20, 0 by 20, that will give 0 only. So after calculating u value, immediately we are calling one more user defined function called compute Bezier points. Compute Bezier point. So this compute Bezier point will take number of arguments like this: u value 0, Bezier curve points 4, Bezier curve points not 4, Bezier curve points 4, okay, and number of control points 20, and we are using pointer concept also. We are using pointer concept here. So this B, whatever the compute Bezier point function returns, that result has been stored in this variable called C. So we are using pointer here. The whatever the C I written, it is a pointer. It is pointer. Now we called compute Bezier point. As soon as you will calculate U value, you will call compute Bezier point. So now compute Bezier point, the control jumps here. See that I written red color here. After once now Bezier curve called binomial coefficient function, and it is executed already. And Bezier function, now it's calling compute Bezier point function. Now control jumps to, see that red color, compute control jumps to compute Bezier point control here. Now compute Bezier point function, it starts calculating what is the pixel position, what is the each pixel position along with that particular curve, particular curve. So from first control point to last control point. So first control point P naught, last control point is nothing but number of control point, that is nothing but 4. 0 to 4, that is nothing but we need to calculate 0 to 3 only we have to calculate. Now to calculate this, we know that formula, blending function k comma n. First time k is 0, next time k no, it is not 0, it is 1 here. From k equal to 1 to number of control points, then substitute k is 1 here, next time it will become 2, next time it will become 3, next you need to stop. Number of control points minus 1 it is. Okay, no problem. You start from k equal to 0, next 1, next 2, next 3. So after calculating what is the x coordinate position and y coordinate position for that particular pixel, for that particular curve, now control goes back to Bezier function. Now we return plot pixel. Plot pixel means that pixel information is displayed on the screen of the monitor. So this will be repeated 20 times per curve. So this loop is repeated 20 times per curve. But in our program we are creating 24 curve in each call. So when you are creating 24 curve in each call, we need to calculate what is the each pixel x and y coordinate. We need to calculate what is the each pixel coordinate position with respect to x axis and y axis for each curve out of 24 curve, out of 24 curves like this, so this is about how exactly control will flow. Now I will go to program. I will discuss how exactly we return this particular program. So as you can see the heading written comment line, develop a menu driven program to animate a flag using Bezier curve algorithm. So in this program, we defined pi value. So whenever we want to create animated images, definitely we need trigonometric functions or trigonometric concepts. So we defined pi value is 3.1416. So whenever we want to create each pixel x-axis, x coordinate position, y coordinate position and z coordinate position, we are creating one structure. As you can see that I created one structure called point that contains three members of type float like x and y and z. This is nothing but x coordinate position, y coordinate position and z coordinate position. So this is about global variables. Like in the global area we declared all these things. Now directly I'll go to the main function. So as you can see the main function, so in the main function we know all these things. But the new thing is here, see that here the first time I am using glut underscore double. In almost all the lab programs I was using frame buffer was only single, glut underscore single. So when I want to display static image or only one image, I need only one frame buffer. But here we are displaying animated image. When you are displaying animated image, I said we need two buffers. One buffer we need to read the content of the image, and one more buffer we need to display the content of that information on the screen of the monitor. So this is the new special thing with respect to this particular program. So as usual, we are creating window position, window size. These all are things are we already explained in all the 8 programs. Now main function, it calls one of the user defined function called my display. So when you call my display function, then control jumps to my display user defined function. So as you can see that my display user defined function is there here. So in this my display user defined function, I said already number of control points we are using 4, number of pixels we are using 20. So initially theta value is 0. So when theta value is initially 0, we are creating flat surface of the flag. Theta is 0. Please you remember theta is 0. Now control points are 4 control points are there, like I written first control point 20 100, second 30 comma 110, third 50 comma 90, fourth 60 comma 100. I written already in the slides, I traced that. Now after defining control points, now whatever the trigonometric function I am using here with respect to x-axis and y-axis, this is the code we are using to flap the flag, to flap the flag. But here now I am using here I am using theta value 0. So when you substitute theta value 0, this code will not affect theta. When theta value is 0, this code will not affect. Initially you will get flat surface. When theta value is gradually it's increasing, or slowly when it's increasing by 0.10, then flat surface of the flag starts flapping, and it is flat surface is converted into curved surface because of the animation is concept is applied here only theta value we are giving motion to sequence of images is nothing but incrementing theta value recursively, and we are substituting the theta value here. So when you substitute the theta value here, every time you will get new coordinate position for the pixels. So when you get new coordinate position for each pixels, then we are displaying new pixel position on the screen of the monitor, but our eye cannot able to catch. We are displaying new image on the screen of the monitor, but our eye can feel that that image is flapping, or that image is flying, or that image is rippling. Our eye feels like this, but in reality we are displaying multiple images, or we are displaying sequence of images because of the motion. When you give the motion to the sequence of images, it will become animation. Now let us begin with this, let us continue this. And each pixel size we are defining 0.5. Each pixel in our flag, or each pixel in our curve of size is 5. And initially we need to display flat surface. When you want to display flat surface initially, here see that flat surface, see that here, if you want to display initially flat surface here, I need to define line width. So I define line width here. So I define line width, that is nothing but here 5. I define pixel size also, I define line width. Why I define line width means, before flapping that flag, or before rippling that flag, the shape of the flag is like a flat surface. When shape of the flag is flat surface, then we need to create horizontal lines. To create horizontal lines, I need to define what is the width of each horizontal line. So this is about how to create flat surface. Now if you want to create flat surface, first time, see that here, first I need orange color. So if you want orange color, curved line, curved surfaces or curves, this is the code, red R G B. So I specified in the intensity level red, green, blue. So the intensity level I specified red, green, blue is nothing but this value. This value creates 8 curves of orange color, and I return I equal to 0. 0 means first curve, 1 means second curve, 2 means third curve. Like this, when I value becomes 7, I value becomes 7, it means it is a 8th curve I created. So code, by using this code, we are creating 8 curves, 8 curves of orange color. So as we know that my display will call internally Bezier, Bezier will call compute Bezier, compute Bezier. We have a binomial function, coefficient function call. Like this we are internally in control flow diagram. I clearly explained how Bezier function definition create one Bezier curve, and how it will calculate u value, and how after calculating u value it will call compute Bezier curve function. How compute Bezier curve function, it will calculate blending function value, and it will calculate x coordinate position, and it also calculate y coordinate position, and finally it returns result back to the calling function. So calling function will create one curve. So here by using this particular for loop, we are creating 8 curve of orange color. Similarly, we have one more for loop here. But before for loop, I return GL color 3F. So this function assigns white color for next 8 curves. So the next I am creating next 8 curves by calling Bezier function. But this 8 curves is of type white color. Similarly, I am creating 8 other curves of type green color, right? Now I created 8 orange color or saffron color curves, 8 white color curves, 8 green color curves. But if the motion is not given, if the theta value is 0, it means that we created 24 horizontal lines. It is not curve, it is a 24 horizontal lines. When theta value is incremented slowly by 0.10, then our flag looks like it's a flapping. When flag starts rippling, then each horizontal line looks like a curve. At that time, we are calling this function. We are creating totally 24 curves, 24 curves with motion, with motion. Now, with motion. Now what we did means by using this code, we created only 24 curves, but we want one pole. We want one pole too for the flag. If you want one pole, then that pole is nothing but one line segment. See the image. This pole is nothing but one line segment. So if you want to create one line segment, we are supposed to specify two endpoints of the line segment. So here I return GL underscore lines, and here it will create one pole that contains two endpoints. So I created one pole. So after creating one pole, we are using here post redisplay. So why we are using get post redisplay means it required only for the animation. It required only for the animation. It continuously multiple times it will display. It will call my display function. When it calls repeatedly my display function will repeatedly it calculate what is the new coordinate position for each pixel for each curve out of 24 curves, and we need to swap the buffer. So swap the buffer means after displaying the one curve image information, immediately theta value is incremented in the program. When theta value is incremented in the program, the again we need to display the same curve in the different place. Means the flat surface line is converted into curve. When flat line or horizontal line is converted into curve, immediately the new image has to be displayed on the screen of the monitor. So then we need swap buffer function call. So this is about how we need to display animated flag on the screen of the monitor. This program also uses viewport concept and two-dimensional viewing concept, the GL viewport concept, two-dimensional viewing concept. So these all are the things we also already discussed in the previous lab. But today we discussed how we need to create animated image on the screen of the monitor. Thank you. And if you run this, I'd like to run this program. If you run this, see the output. I would like to show the output also. See the output. See that. Please, you see the output of this particular program. So first flat surface flag is there. That time theta value is 0. When I incremented theta value by 1.0, see that flat surface flag converted into curved surface flag with flapping. Now I can say that I created one flag. It is a flapping or it is a rippling. It is a rippling here, and we have a one pole here. We have one pole. So this is called animated image. So in the fifth module, we are learning how we can project sequence of images with motion. So we know that sequence of images with motion is called animation. So this is the one of the basic example in computer graphics to create animated images on the screen of the monitor. So this is the output of this particular program. Thank you.